In this video we're looking at probability trees in two different ways. In one, the probabilities are going to change, and in the others the probabilities stay the same throughout the tree. So let's look at the first. A probability tree is most useful when there's more than two events. If there's just two events, we can usually use a two-way table or a sample space, but when there are more than two events, for example, the working out the probability of 3 children in a family, how many boys, how many girls, you can't fit that onto your sample space because you can only have two sides. But with a probability tree, you can have more than two events. Or tossing a coin 3 times. We can, on a two-way table, you can toss it twice or 2 different coins. But with a probability tree, we have more options. And the probability tree usually is from left to right. And we write the probabilities, you can see at the bottom of this page, we write the probability in either decimals or fractions or percentages. And the most important thing here, I think, is that along the branches, we multiply the probabilities along the branch to have an outcome at the end. So we'd multiply the decimals together, or we have to multiply the fractions. Take care, you remember how to multiply fractions. And then if we have different branches that we want to add together, we can add those at the end. And each individual set of branches has a probability of 1. So here, to have a head is 0.5, to have a tail is 0.5. You add those together and you would get 1, which is 100%. This will become clear as you work on the tree. Next one, this is an example. It's from my PowerPoint, so it's kind of got the answers here already. But we're told that a cafe sells coffee and tea. 40% of customers order coffee, so we can use the decimal 0.4 or 0.40. And assuming a 40% drink coffee, the rest 60% drink tea, so we can write 60% on there. Then we're told that 30% of the coffee drinkers add milk, so our 30% goes up here. If 30% have milk, we can write in, we know that 70% must not use milk. That's a lot of people who don't have milk in their coffee. Okay, and lastly, of the tea drinkers, 80% have milk, which we've written here. 80 and 0.8 are the same. And if 80 have milk, then 20% will not have milk. Question 1 asks us here, A, if a customer is chosen at random, calculate the probability they drink tea with milk if they buy their beverage from the cafe. So I'll use a different colour, maybe green. We multiply along the branch. So they're having tea with milk. So tea is here and milk is here. So it's just that one branch. So it's going to be multiply along the branch 0.6 times 0.8. Or if it was a fraction, perhaps we had 6 out of 10 times 8 out of 10 would be 48 out of 100. Or this is 0.48. Okay, we just asked for a probability. Part 2, B here. Calculate the probability that a customer chosen at random adds milk to their drink. So we're looking at finding who adds milk. So there's milk here and milk here. But we can't just add the 0.3 to the 0.8. That becomes 1.1, 8, 19, 11. And 110% is too much. You must remember that this 0.3 belongs to the one here. These belong together. And this 0.8 belongs with the 0.6. So we multiply along the line. We find that 0.12. and we add it to our 0.48 when you times those two and times those. And then we add the probabilities at the end. So the probability of having milk is going to be 0.48 plus 0.12, which gives us 0.6, 60% of the customers. Okay, next page. A market research firm carries out telephone surveys, those lovely people that call you at home on the telephone and ask you questions. So, who's going to pick up the call? It's found that usually 55% are answered by females. Okay, so we can start our tree. We've told 55%, 0.55 are female, and 0.45 are male. Who pick up, the females pick up more than the male. Right, draw the probability tree to show the possibilities after two consecutive calls. Consecutive, one after the other. So we've got two calls happening. So the next call, again, first time maybe it was picked up by female here. The second call, again, it could be picked up by a female or a male, and we know those probabilities. 0.55. Or perhaps the first time it was picked up by a male, the second time it may be picked up by a female or a male. 0.55 and 0.45. The question is, what's the probability that both calls were answered by females? Well, I look on the table, here's female and female there. Again, multiply along the branch. So 0.55 squared, or 0.55 times 0.55 on our calculator, gives us that probability. The second question, sorry, it's on the next page, but it's what's the probability that the telephone's answered once by a male, once by a female? So that could be answered by a female, then answered by a male, or answered by a male and answered by a female. So it would be 0.55 times 0.45 equals, and exactly the same down here, 0.45 times 0.55 equals, and we add those two answers together to get our final probability for either a male or a female picking up, but one of each. Well, that's just those questions. You can look at that again and practice that one. Next question, this gets a bit complicated. We're at the horse jumping national steeplechase at Riccarton. There are 3 types of jumps, and how many falls are there at these jumps? Not falls, but falls, which will involve quite a big tree. So the first probability is the first jump is called jumbo, and the probability of a fall or not a fall, sometimes you might see F dash, which means not a fall, is probability of a fall is 0.5 here. So it must be 0.5, not a fall. And then the next one is the carriage paddock, CP, and the chance of having a fall here is 0.3. 0.3, so not having a fall would be 0.7. And the last jump is Cuts Brush. Oh, amazing names. Chance of a fall there obviously is quite difficult because it's a 0.6. 60% chance of a fall on that one. And all of these can have the same. Not having a fall there is 0.4, or a fall. Not having a fall or a fall. Not having a fall or a fall. So the question is, what's the chance of having no falls after these 3 jumps at the Grand National Steeplechase. Boy, let's see. What's your chance of the rider not falling off the horse at the steeplechase? So, if I want to find not falling, it's NF, and I want not falling is going to be, I'll just find another colour, let's do blue. Not falling here, there's a not falling on the first jump, not falling on the second jump, not falling on the last jump. So the probability is 0.5 times 0.7 times 0.4, which I'm kind of interested to see how that works out. Let's see. 0.5 times 0.7 times 0.4 equals 0.14. So you have a 14% chance of not falling. Ooh, so the chance of falling then would be 1 take away 14%. So 86% chance of falling. Right, because that was not falling. Only a 14% chance of not falling. So you have a huge likelihood that you'll fall on the horse in the National Steeplechase. 86%. Boy, who would ride that? Okay, the next one. We don't get too carried away with this one. And that's the chance of falling at only one. The next one here is sampling without replacement. Often when sampling from a fixed number of outcomes, the probabilities change from branch to branch. Be aware of changing probabilities. If you see the words not replaced, if a ball is not replaced, if a marble is not replaced, or a situation where one item is chosen and then another, then we have to change the probabilities. So I'll show you that in this slide here. An urn contains 12 marbles, numbered 1 to 12. A marble is drawn from the urn, is not replaced. Okay, find the probability that both marbles are numbered less than 5. So that must be marble number 1, 2, 3 or 4. So if it's less than 5, there are 4 of them out of the 12 here. And if it's 5 or more, there must be 8 of them out of 12. Okay, if I take a marble, let's say it's a 3, it's less than 5, then I pick a second marble, I've already got the 3 out, so there are only 3 marbles that are less than 12. Sorry, 3 marbles are less than 5, but it's 3 out of 11 marbles because I've taken 1 marble out. Okay, so that's the probability on the other one, that it's less than 5. The probability that it's 5 or more, there are still 8 in the bag, 8 in there, but it's out of 11 that it's 5 or more. And here, if the first marble I took was 5 or more, instead of being 8, there would only be 7 out of 11 left. That would be 5 or more. And that's less than 5. If the first marble was more than 5, then I still have only 4 that are less than 5 out of 11 left. Okay, so the question here, find the probability that both marbles numbered less than 5. So I'm going to multiply 4 twelfths times 3 elevenths to get my answer. Times, 4 twelfths times 3 elevenths, sorry I'm tired, is the same as 12 over 121, which equals 1 over 11 is the probability there. And last one, class of 25 students, 10 girls, 15 boys. 3 students are chosen. Calculate the probability that all the students were girls. Okay, so first time I choose a girl or a boy, the girls are 10 out of 25. Now I've chosen a girl, so there are only 9 girls left out of 24 for the second girl. And then I choose another. If that's a girl, there's only 8 left out of 23. So, and again, this would be, there would still be the probability of a boy each of these times. Girl, boy, a girl or a boy, girl or a boy. Whoops, don't really need that. So I have to multiply these fractions together to find the overall probability that the students were all girls. Okay, and that I think, thank you and see you later.